Hi guys, Mrs. Patton here to talk to you about work and power. You should have already started with a few activities that deal with these, and what we're going to do today is we're going to talk a little bit about how those activities tie into each other and really to the meaning of work and power. So, the activity that you've done was a lab, and about that lab, there's a few things that you should have gained from that experience. First off, work is directly proportional to both force and displacement. This means that if I increase the amount of force that I need to apply to an object, or I increase how far it goes between its starting point or its ending point, I'm going to be doing more work on that object. Similarly, work only counts if force and displacement are in the same direction. So the force actually has to cause that displacement in order for work to be done. Finally, we also learned that work can be positive or it can be negative. Or maybe we didn't learn that, but we will. In order to kind of get to the point of what work is, I want to set up a scenario for us. And that scenario is just going to be a person going on an escalator. Here's our person making his way up the escalator. Now, as our person reaches the top of the escalator, we can ask what work was done on that person. Now, in order to figure that out, the first thing that we need to know is what forces that person is experiencing, or what forces the escalator needs to overcome in order to move that person. And the main force here is gravity, or the force of weight on that person. The force that the escalator needs to apply is going to be the upward force to combat that force of weight. That upward force is just going to be normal force. So, for our escalator moving upward, the force that we need to consider is the normal force of the escalator on the person. The escalator is moving to the left and the right, but it is not applying a force to our person as it does that. It's just moving in and of itself. It's not forcing our person to the left or right. Now, this person's also going to undergo some displacements, and we know based on our study of vectors and things that we've done that have had two dimensions in the past, that our person is both going to have a horizontal displacement, moving from left to right, and a vertical displacement, moving from bottom to top. Now, we said before in our definition of work that only the displacement in the direction of the force matters, meaning that even though I have both a horizontal displacement and a vertical displacement, only the vertical displacement counts when it comes to the work that is done on our person. Now, this is pretty straightforward, and as long as those two things are in exactly the same direction, our vertical displacement and our normal force, in this case, we can find the work pretty easily. Work is just force times the displacement. Work is measured in Newton meters because force is measured in newtons and displacement is measured in meters. And the other alternative unit that you could use is what is called a joule. And you're going to become very familiar with joules as we go through this unit that we're working on right now. But joules are represented with a capital J. You won't always have force and displacement in the same direction. And obviously, in this case, we don't really have force and displacement in the same direction. We're looking at just that vertical aspect of our displacement. So what we can do is we can come up with a more general version of our work equation. And the way that we can do that is we can consider how much of our overall distance that we've traveled is in the vertical direction. All we need to do then is we need to kind of break our triangle down, looking at the angle theta and the distance r, finding that vertical displacement to be r times the sine of theta. So when we're looking at our work, what we need to do is we need to multiply our overall displacement by the sine of the angle in between our force and our distance. Or work equals force times distance times the sine of the angle in between. You're not going to have to worry about this at any point, but I just wanted you to be aware of that. Now, here's the key. If force and displacement are in the same direction, meaning that the angle between them is 0, our work is positive. But if force and displacement are in opposite directions, meaning the angle between them is 180 degrees, our work is negative. That means that in this case, because our force and our displacement are pointing in the same direction, we're doing positive work, but had we gone back down the escalator, we would have been doing negative work. This means that if you lift something into the air, you do positive work on it. And if you put it back down, you do negative work. If I add those two works together, what I'll find is if I lift something and then place it back where it came from, I've actually done no work on that object because I've done both that positive and that negative work. Work is a vector in a way, meaning that my positive and my negatives will add up to 0. Now, works can seem a little bit complicated, but it's not that bad. Really, all you're doing is multiplying your force and your displacement that's in the same direction. If you want to go the next step and talk about power, which we also considered in our lab, that's a little bit more simplistic. Power is just equal to the amount of work that we do in a given period of time. So power is equal to work divided by time. That means its units are joules per second or just watts. No, not those kinds of watts. If we wanted to increase the power that we generate in a particular scenario, what we would do is we would increase the force that was applied, increase the displacement over which that force is applied, or decrease the amount of time over which the force is applied over the displacement. This just means that there are 3 different variables that I can change in order to change the amount of power that I generate. Power and work are going to tie in pretty interestingly into energy, which we're going to be considering for the remainder of this unit. So what I wanted you to do is build a nice familiarity with these 2 concepts, work and power, and we're also going to tie them into simple machines at some point during this unit as well. If you have any questions about work or power, please don't hesitate to ask me, and I look forward to seeing you guys soon.